So what if an AI could do more than just understand what you're asking? What if it could seamlessly pull together hundreds of different tools to actually get the job done? Well, that's the future we're diving into today, and it's a massive leap forward for building truly smart AI agents. And this is the big vision, right? We're talking about AI assistants that can orchestrate pretty much everything, from the IDE on your laptop to your company's entire operational stack. But, getting there is not as simple as it sounds. So today, we're going to break down the gap between that vision and where we are now. We'll look at 3 really powerful solutions that are closing that gap, and then we'll explore what this new age of AI agents really means for all of us. Okay, so trying to build this perfectly orchestrated future, well, it runs into a massive wall. And it all starts with just the sheer amount of information an AI has to deal with just to know what tools it can even use. Take a look at this number, 55,000. That's how many tokens, and you can just think of tokens as little pieces of words or code. That's how many it takes just to load the definitions for only 58 common tools. We're talking about services like GitHub, Slack, and Sentry. And here's the real kicker. All of that happens before the AI even gets to look at what you asked it to do. It's the core of the problem. The tool descriptions themselves are eating up the AI's entire context window, which is basically its short-term memory, and it leaves almost no room for your actual request. It's kind of like filling your whole workbench with user manuals, leaving you no space to actually build anything. The tool definitions alone can gobble up a whopping 95% of the AI's memory. That leaves a tiny, tiny fraction for the actual task you want done. It's just not workable. So, this leads developers to 3 huge bottlenecks. First, you've got context window bloat, which is what we just talked about. The tools take up all the space. Second is data overload, where the output from one tool just clogs up the whole system for the next one. And finally, there's parameter ambiguity, where the AI knows what a tool needs, but has no idea about the specific format, so it just fails. All right, so let's get into the first big breakthrough. This one tackles that context window bloat problem head on. This has been a really fundamental challenge for a while now. I mean, how do you give an AI access to a massive toolbox without completely overwhelming it? Well, the new approach is surprisingly elegant. See, instead of handing the AI the entire massive toolbox, you just give it a smart catalog that it can search through instantly. This on-demand system lets the AI dynamically find and load only the specific tools it needs for whatever task is at hand. And the impact here is just staggering. The old way would eat up around 77,000 tokens. With this new tool search approach, that number plummets to just over 8,000. That's an 85% reduction in token use, which frees up a huge amount of working memory. And it's not just about saving space either. When the AI focuses only on the relevant tools, it makes much, much better decisions. We're seeing accuracy jump by over 8.5 percentage points, hitting a new high of 88%. Okay, so we found the right tool. That's a huge step. But what happens when a task is more complex? When it needs multiple tools and it's creating tons of data along the way?
Well, the old method is just painfully inefficient. The AI calls a tool, and this huge raw result, maybe a giant log file, comes back and clogs up its memory. Then it calls another tool, and another massive result comes in and shoves the old information out. The poor AI is left just trying to eyeball all this raw data to piece together an answer. It's a mess.
This new feature, programmatic tool calling, is a total game changer. It basically turns the AI from a simple tool user into a project manager. It actually writes a little piece of code on the fly that orchestrates all the tools, processes all their outputs, and then only returns the clean, final synthesized result. It just handles all those messy middle steps for you. And the efficiency gains here are just massive. Token usage drops by 37%. Latency completely plummets. You're going from over 20 back-and-forth API calls down to just a single trip. And maybe most importantly, accuracy goes way up because the logic isn't guesswork anymore. It's written explicitly in code. Okay, so the agent can find the right tool and it can execute it efficiently. But how does it learn to use that tool correctly? This is the third and really crucial piece of the puzzle. This is where we solve those subtle problems that cause tool calls to fail. You see, a tool's schema is kind of like a dictionary. It defines the words, but it doesn't teach you how to write a sentence. It tells you what parameters are valid, but not how to use them. And here's a perfect example of that exact problem. On the left, the schema just says a due date is a string. Okay, great, but is that year, month, day? Or is it November 6th, 2024? The AI is forced to guess. But look at the right. An example provides a crystal clear blueprint. It shows the exact format, and suddenly all that ambiguity is gone. That's what these tool use examples do. And the result of that clarity? A huge leap in reliability. Internal tests show that accuracy on these kinds of tricky parameter tasks jumped from a pretty mediocre 72% all the way up to 90%. No more guesswork, just reliable results. So let's tie this all together. Let's take a look at what this new reality for AI agents really looks like. What we have here are 3 breakthroughs that are designed to work together as a single, complete system. Tool search solves the problem of discovery. Programmatic calling solves execution, and tool use examples solve invocation, using the tool correctly. Together, they are the foundation for a whole new generation of much smarter, much more capable AI agents. This is a really big deal because it shifts tool use from just simple function calling to truly intelligent orchestration. It's opening up a whole new frontier for what's possible. The question isn't just about what these agents can do anymore. The real question is, now that they can discover, orchestrate,